Hello everyone, welcome back to another video of data series using Pandas. In this part of the video, we're going to be talking about the mathematical operations that we can perform on data series. Now, what do you mean by mathematical operations? Operations such as addition, subtraction, division, floor division, modulus, etc. Okay, so let's get going. In my example, I have shown you the addition operation. But if you understand the addition operation, you can perform any other operation as well. Okay. So let's assume these are the two, series that I have with me. Series X and series Y. Okay. So just for your understanding, let me just, draw out that series for you. So your X series would be something like this. The values given in the series are 2.5, 3, 4.5, 5, and 6. And since no index labeling is given, it's going to take the positional index, and that's how your X is going to look, correct? Okay, coming to Y. Okay, Y, the elements of Y are 7.5, 2, 1.5, 8, and 10. And again, here, since no index is given, it's going to take the positional index, which is 0, 1, 2, 3, and 4. Okay. Now, what happens when we say X plus Y? All mathematical operations on two series are done on the corresponding elements having the same labeled index or positional index, which means this element at label 0 is going to be added with this element at label 0 to give you another element at label 0. Similarly, element 1 gets added, element at index label 1 gets added with element at index label 1 in Y, and you get the answer. Is that clear? So let's just see what my answer would be. Okay, now can you see here you've got your answers. Let's see how that was calculated. So you have 2.5 plus 7.5, and mind you, I've done the addition operation. You could have done subtraction. You could have done multiplication, division, floor division, okay, exponent, up to you. Any of those mathematical operators that we have learned, or arithmetical operators we have learned. So 2.5 plus 7.5 is giving me 10. So I get a 10 here. What I need to realize is it is with index. So the addition of two series is also going to give me the answer as a series. That is the reason you're seeing the positional indexes as well. Okay. 3 gets added to 2, giving me 5, and so on. Okay. Now, the question that can arise in your mind is, what if X has 5 elements and Y has 4 elements? Then what happens in that scenario? I will clear your doubts with my next screen. Is that clear? So I hope this is understood. Okay, let's go to my next screen. But before that, let me just clear up some annotations. Maybe this is the same series I will need in the next screen. So let's get ahead. Okay, so you have series X with the same values. I haven't changed the values. Now series Y, if you see, I have 7.5, 2, 1.5, and 8. So basically what have I done? I have reduced one element here. Okay, so now what happens is the number 4, that's the label 4 in X, does not have a matching label in Y. Then in this scenario, what happens? Every missing element is going to be replaced by NaN. You remember this NaN we have been learning from the NumPy chapter. Basically stands for not a number or absence of a value, like the null in MySQL. Here it's going to be NaN. Okay, so any missing value is going to be substituted as NaN. And any operation that you do with NaN, so you will get NaN itself. We've learned that in MySQL as well. that if you perform any operation with null, the result is null. So here, instead of null, you will get NaN. Okay, so just let's look at the output here. Can you see at index label 4, you see a NaN? That's the reason being the first series had the label called 4 with value 6, but there was nothing to add that to. There was nothing to be added to it in series Y. Okay, so we are getting NaN there. Clear? So did you understand? Now it's not necessary. Now this is positional labels. Okay, it's not necessary that we work with only positional labels. We have seen series with other labels, named labels that we could give. Okay, so let's look at all those options as well. Now, in this series that you see here, I have created a series where I have given label names. So let me just draw the series X for you. The values continue to remain the same: 2.5, 3, 4.5, 5, and 6. And now, instead of using the positional labels, I'm using the named labels. So I have A, B, C, X, and Z. Okay, I have Y also with me. Let me draw it here. Okay, I have Y also with me with values 7.5, 2, 1.5, 8, and 10. And the labels are X, W, Z, A, C. Okay, now remember what I said in the previous slide. I told you that labels with the values with the same labels are operated on. So I have to add A only with A and not the first element with the first element. Now, obviously the positional indexes are 0, 1, 2, but now since you give a named label, then we work on the named label. So A's value, that's 2.5, gets added with 8.5 to give you the answer. B, now pay attention. B is 3 here, but there is no B that exists here. So absence of a value means NaN. So 3 plus NaN finally gives me NaN. Okay, then you have a C here. 4.5 gets added to 10 and you get the result. Now you have X here. 5 gets added to 7.5 and you get the result. You have Z here. 6 gets added to 1.5 and you get the result. Now you have another element W here which doesn't exist here. So for label W and label B, the value associated with it is going to be NaN. But another important thing is in which order are you going to be seeing the data? You're going to be seeing the data in the ascending order of the labels. So I just want to show it to you here. This is how your output looks. So you got A as 10.5. Look at the screen carefully. In X, A is 2.5 and in Y, A is 8. So 8 plus 2.5 is 10.5. We had a B in X, but we did not have a B in Y, so NaN, and so on. So, and can you see the labels are in no order in terms of how it was in the series? It is in alphabetical order, okay, so, or ascending order. So I have labels A, B, C, W, X, Y, Z. Doesn't matter in which series did these labels appear. It doesn't matter. Is this clear? Okay, so here, remember in all the 3 examples, we have used the addition operation. You could use any of the operations that we have learned, that is subtraction, multiplication, division, floor division, modulus, or exponent. Okay, now there's another way of, performing mathematical operations. Let me take you to my next screen. Okay, but that's using functions of the data series, okay, not by using the mathematical operator, not the symbols, but functions. Now, what's the advantage of having functions? Now, when we have a function, the absence of a value can be substituted with a certain value that you specify in the function. I repeat, the advantage of using a function over an operator is the absence of a value can be substituted by a value that you specify in the function. To understand that, my X and Y series happen to be the same. Look at the function that I'm making use of. I'm using a function named add. Okay, so it's X dot add, and the what are we adding to X? Y. So in normal terms, I could have just written X dot add in bracket Y. So the elements of X gets added to the elements of Y, and you get a resultant series. Okay, but here in this example, what I just showed you, NaN values can appear because you did not specify that you need to replace non-existing values with certain values. Now look at the example that you see on the screen. I said fill value, fill underscore value is the parameter of the add function. And I said fill value is equal to 0. Understand this line. Fill value is equal to 0 means that any absence of any value is going to be filled up with value 0. Okay, let's look at the output so things would be more clear to you. Now, A we know was 10.5 even earlier. Now look at B. B previously we saw as NaN. Now, B is 3. The absence of B in series Y is going to be filled up with 0 because we said fill value is 0. So 3 plus 0 is nothing but 3. Similarly, you remember W was missing in the first one. W is 2 here. W is missing here. So the missing value is going to be treated as 0. 2 plus 0 is 2. So can you see with W, we have got the value 2. Now, instead of fill value 0, what if I had written something else? Now, for example, I wrote 10. Then what would happen? You would see this as 13 and you would see this as 12, which means the missing value, I want to represent it by value 10. So 3 plus 10 made it 13 and 2 plus 10 made it 12. Is that clear? So you see an advantage here. We will never get a NaN value if we give a fill value. But if I had just written X dot add Y, obviously you could get a NaN value as well because you have not given the fill value. Clear? Okay. So this was all about the addition operation. Okay. What about subtraction? What about multiplication? What about division? What about floor division? What about modulus? And what about, let's say, exponent? You can use any of these operators as well. And the functions for each of them would be sub for subtraction, MUL for multiplication, div for division, floor div for floor division, mod for modulus, and POW for exponent, which means if I write X dot POW Y, okay, what does this mean? X star star Y, which is X raised to Y, and you would give an answer. But remember, you don't have a fill value, so you could be seeing a NaN value as well. Is that clear? So I hope you have understood all the mathematical operations that you can perform on a data series. You could be performing these operations either by using mathematical operators, that are those symbols, or by using these functions named sub, mul, div, floor div, mod, POW, and add like we see in this example. Okay, so I hope things are clear. Okay. And I hope you've understood everything. Okay, see you in the next video. Bye. Thank you.